Welcome to this course, Machine Learning for All, and we are in the Model 2, Topic 3, that is classification problem type of problem. So already in the topic 1, we have discussed about different type of supervised learning type of problems, and this is the second type of problem we can solve with the help of a supervised learning. Now, what is classification problem exactly is? Classification problem is a type of problem where machine try to actually identify a category or a type of class based on the previous experience or already available training data, where actually the labels are or the predefined class or categories are available. And supervised machine learning models consider the feature values as the input, and definitely your already mentioned category or class as the output of in this kind of problems. Now, in this picture, if you just see a simple example or a simple representation of classification problem is presented, where you have 4 features are available and 3 classes for your output or 3 categories are available. Definitely you can connect or you can map this kind of problems with some real life problem like spam detection, whether a particular email is a spam or not, or let's say sentiment analysis, whether people are liking a particular product or not based on the review, or maybe you are trying to identify whether it is a 1, 2 or 3 and disease diagnostic, whether you are a COVID positive or COVID negative. So these kind of problems are nothing but the classification type of problems, and they can be easily solved with the help of supervised learning approach. Now again, different available models are popular, but in this course we will be largely covering the algorithms like logistic regression based classifier, k nearest neighbor based classifier, and decision tree classifier for the demonstration, where you will be learning how these models can be used to solve some problem, real life. Now, after this, that you have a model evaluation. So definitely in case of regression problems, you have different set of features, and in classification there are different set of features. Right now, if I just consider that only there are 2 class or 2 levels or this kind of decision making you have to do, whether I have to do that particular job or not. So in that case, you can simply represent, if I have to do particular job, then it is 1. If I should not do that job, it should be 0. And definitely 1 can be considered as a positive and 0 can be considered as a negative. So there is a concept of confusion matrix which actually tells that which type of category you are predicting properly, and based on that also you can derive some of the matrices which can tell how well your model is performing or predicting. Now, in the confusion matrix, you have 4 types of observation. One is true negative, where real negative observations are rightly predicted or identified by your algorithm. And then you have false negative, where actually ones are predicted as 0. So basically the false negative predictions. Then true positive, where definitely the positive cases are predicted as positive, and false positive, where class 0 or category 0 cases are predicted as class 1 or category 1. So using these values also, or these numbers also, I can generate some of the or derive some of the matrices. Like accuracy. Accuracy is nothing but how well your machine learning model predicted accurately 1 and 0 cases. Then comes the precision. It indicates the proportionate of accurately predicted positive cases or ones by the model out of total positive case prediction. And then recall, this indicates the proportionate of actually predicted positive cases by the model out of total actual observed positive cases. F1 score, this is nothing but the combination of your precision and recall, where we try to find out how well your model is maintaining precision and recall, and this type of score or F1 score is very useful in your training data. A huge imbalance of class is mentioned, or your data itself is little bit biased toward one class. Now in this case, in this slide, here you can see the 4 formulas or expressions for these different matrices, derived matrices: accuracy, precision, recall, and F1 score. Now, from this formulas also, you can easily understand how they should be measured. And finally, F1 score, which is nothing but the combination, or it is nothing but integrated uh, a matrix of precision and recall. You can consider, you can find out by multiplying both of them with the 2 and divided by the summation of precision and recall, which is nothing but harmonic mean of precision and recall. Finally, in the summary, I can tell that in case the classification type of problem is nothing but you are trying to identify a predefined class based on previous experiences. Maybe you are trying to identify a cat, or you are trying to differentiate square from triangle. Maybe you are trying to find out, okay, whether a particular email is spam or not. And in that case, you are trying to teach your machine, or you are trying to tell him, or tell your machine how to actually predict the right cases with the help of training. And here some of the matrices, the performance measure you are using, that is, first is confusion matrix, where you are trying to find out how many right predictions are generated through your model. Then based on that value, also you are trying to create how well it is predicting a positive case, or how much accurately it is predicting a particular case. And finally, when there is an imbalance in the data, with the help of F1 score, you are trying to find out how well it is maintaining a high value of precision and recall. Now, here I must say all these performance measures are lies within the 0 and 1. So, the value is always below 1, and the higher value indicates a better model, and lower value indicates it need more improvement or need training. Maybe with the more number, or maybe you can say that quality of data you have to improve. And at the end, I should say thank to all the learners. Thank you.